Welcome to Easy Maths. In this video, we will be graphing linear inequalities, and this is part 2, the final part of a two-part series. Now, in the previous video, we learned how to draw linear inequalities individually. We also learned how to identify the region for those linear inequalities. In this video, we're going to be finding common region for multiple inequalities. So these three inequalities, we're going to be using one grid to draw the inequalities and identify the region that is common to all, the region that satisfies all these inequalities. And then we're going to label that region R. For x is equal to -1. For the second inequality, where it says y is greater than 5, we need to draw the graph for y is equal to 5. And in the third inequality, we need to draw the graph for y is equal to x plus 3. Now remember, if the inequality says equal to, then we use solid lines. If it does not say it's equal to, we use broken lines. So let's get straight into it. So we need to draw a solid line at x is equal to -1. So we identify -1 on our x-axis, and we draw a line going through our -1 on the x-axis. And then, as usual, I recommend labeling your line. So we label this line as x is equal to -1. It says x is greater than or equal to -1. So we know since x can be equal to -1, x can be -1. X should be greater than it as well. So x can be 0, x can be 2, x can be 3, etc. We need to shade the area where it says it's greater than it. And since we know x can be anything along this range, then we will shade above the line. The next inequality says y is greater than 5. So we draw our line at y is equal to 5. So we search for 5 on our y-axis, and we draw a broken line going through the y-axis at 5. So there's my 5, and I need a broken line because it does not say it is equal to it, which means the values on the lines or the points on the lines are not included. So y can't be 5, in other words, because it must be greater than 5. And we label our line as y is equal to 5. Now, since it must be greater than 5, I know y can be 6, y can be 7, y can be 8, etc. And so I need to shade above this line. So this represents my region for y is greater than 5. Now, in the third inequality, because it has two variables, we can either use the slope and the intercept, or we can create a table of values. So let's create a table of values. So we can select any three values for x and substitute to find y. So let's use when x is 0, when x is 1, and when x is 2. 3 points are enough. So when x is 0, y is going to be 0 plus 3, which is 3. When x is 1, y is going to be 1 plus 3, which is 4. And when x is 2, y is going to be 2 plus 3, which is 5. And then we're going to plot these points. So 0 on the x maps to 3 on the y, which is here. 1 on the x will map to 4 on the y, which is right here. And 2 on the x to 5 on the y, which is this point here. And then we need a solid line because it says it can also be equal to it. So a solid line going through these points That's good enough. And then we label our line. So this line is y is equal to x plus 3. Now, if you wanted to use the slope, the gradient is 1. The gradient is 1. Starting at the intercept, which is 3, you would go 1 across and 1 up. 1 across, 1 up. 1 across, 1 up. And that's how you would use the slope and the intercept if that's the method you wanted. Okay, so because it says it's greater than it, then we need to shade above this line. So let's use a different color for going above the line. Let's use a pink, nice color pink. So above this line will represent my greater than. Gonna have something in common. Now notice we want the area where all these three colors are meeting. And that area is right here. So in this region, I have all the three colors. So this region has all my three colors, which means this is my common area. Right here is my common area. Now I'm going to erase the parts that we don't want. So it is looking. So there we go. This is our common region. Now your turn. Pause the video, have a go at these, and then we'll do them together. Welcome back. So this said shade the region which satisfies the inequalities. So we need all these three inequalities on the same grid. So remember, step 1 is to identify the equation for the line and draw that graph. In the next one, it says y is greater than 2. So we need to draw the graph for y is equal to 2. And the last one says y plus x, or x plus y, is less than or equal to 5. So we need to make y the subject of the inequality. So if we take away x on both sides, we would have y is less than or equal to 5 minus x. Now remember, it's always better to write it in the equation of a line, which is y is equal to mx plus c. Then we rewrite our inequality. Is especially useful if you're going to be using the slope and the intercept. If you're using table of values, it really doesn't matter. So let's use table of values because it is easier for many of you. If you were using for this inequality, if you were using the intercept, we would find where the line cuts the y-axis at 5, and then for the slope, for every one we go across, we would go 1 down. And that's how we would get the line using the slope and the intercept. So let's just do that. So let's plot this line. Let's write the equation. Y is equal to negative x plus 5. Let's plot this line. So our intercept is at 5. And our gradient is negative 1. So we go 1 across and 1 down. So this is our next point right here. 1 across, 1 down. And we have enough points. Now it's going to be a solid line because it says less than or equal to. And we label our line as y is equal to negative x plus 5. The inequality says it's less than or equal to it. So the points on the line satisfy our inequality, but because it says less than, then we need to shade below our line. So we're going to shade below our line. So in this direction. Now let's draw the equation for the graph for y is equal to 2. So we identify 2 on our y-axis and we draw a broken line going through 2 on our y-axis. And then we label our line. So this is y is equal to 2. And then the last one, x is equal to 1. We draw our line, a solid line going through the x-axis at 1. and we label our line. So this is x is equal to 1. Now, y is greater than 2. We need to shade above the line because it's greater than it, this direction. And for the first inequality, x is greater than or equal to 1, I need to shade above that line as well. So this is going in this direction. So if you notice, the area where they all meet is going to be this section right here. This is where they all meet. This is where they all meet. Because for y is greater than 2, this is going in this direction. For x is greater than or equal to 1, it's going in this direction. And for y is less than or equal to negative x plus 5, it's going in this direction. So they're all meeting in this region. Now we can always check to know if we're correct by selecting any point within the region that we've shaded. Then we want to draw a graph for y is equal to negative 1. We want to draw the graph for y is equal to 2 times x. And the next one, we need to make y the subject of the formula. So if we minus 5x from both sides, we will now have 4y is less than 20 minus 5x. And then we divide by 4. Divide by 4. Divide each of these by 4. So y is less than 20 divided by 4 is 5 minus 5 over 4 times x. Now with this one, it's better to write it in the form of y equal to mx plus c, the equation of a line, and this will be especially useful. So, and let's just write the equation that we will be drawing the graph for. So this is going to be y is equal to negative 5 over 4 times x plus 5. Okay, let's start. So the first one says x is greater than 0. So our x is equal to 0. And it says greater than, so we know we'll be going in this direction or above the line. The next one, y is greater than negative 1. So we look for negative 1 on the y-axis, and it's broken because it does not say it's equal to it. And we can label this as y is equal to negative 1. It also says greater than, so we will be going in this direction. We will be going above the line. The next one says y is less than 2x, which means we're going to be doubling the x to get y. So let's do a table of values. So when x is 0, when x is 1, when x is 2. And we substitute. When x is 0, 2 times 0 is 0. Y is also 0. When x is 1, 2 times 1 is 2. When x is 2, 2 times 2 is 4. Y is 4. So 0, 0 is right here. And then 1 to 2 and 2 to 4. And we're also going to have a broken line, because it does not say it's equal to it. It says it's less than it, so we have to be going below this line. So below the line. Let's label this as y is equal to 2x. And for this line, our y-intercept is at 5. So our y-intercept is at 5. And so we know it's going to cut our y-axis at 5, or the line is going to pass through our y-axis at 5. And then our gradient is negative 5 over 4, which means we're going to go 4 across and 5 down. So 1, 2, 3, 4 across, 5 down. 1, 2, 3, 4, 5. So this is my next point. And we don't need more than 2 points to plot a straight line. So that is good enough, and it's going to be a broken line also. We label this as y is equal to negative 5 over 4x plus 5. And because it says less than, we are going below the line. So we're going below the line. Below the line. So where is the region that we have all our arrows? Well, this graph for x is greater than 0 is going in this direction. Yes? For y is greater than negative 1, it's going here. And for y is less than 2x, it's going down here. So our common region, therefore, is right here. This is our common region. And we need to label it R, and we can test. So select any point. So if I select this point, for example, I need to test if it satisfies all inequality. So at this point, my x is 2, my y is 1. So let's just write that. So x is 2, y is 1 at this point. So let's see if it works. X is 2, x is indeed greater than 0, so it satisfies this inequality. Y is 1, y is definitely, 1 is definitely greater than negative 1, so it does satisfy this inequality. And y is less than, and 2 times x is 4, so that is also true. We could solve that. So y is less than 5 minus 5 times x, which is 2 over 4. 5 minus 10 over 4. And 10 divided by 4 is 2.5. 5 minus 2.5 is 2.5. And remember, our y is 1, so y is definitely less than 2.5. So we know we have identified our common region.